Hey everyone, welcome back to Signals. I'm your host, Gwen Chen. Joining me today is AP, CEO of Encycle. We will talk about energy management and smart building. Hi AP, welcome to Signals.
Hey Gwen, how you doing today?
Good. Can you describe what Encycle does and what is the problem you guys are trying to solve?
Yes, I can definitely do that. We were really the first HVAC optimization company, which sounds really fancy and kind of boring all at the same time. But what we're trying to do is we're trying to reduce grid stress. We're trying to reduce the amount of energy that commercial buildings use on a day-to-day basis. And if we reduce the amount of energy that buildings use, one, there's more available energy for other things. But two, it also helps reduce our carbon footprint. So that's what Encycle does on a day-to-day basis. And we just so happen to be one of those companies that deploys things like machine learning and AI in order to do it.
What is HVAC?
And so it's basically what heats and cools if you think about your home. So the unit that's connected to the thermostat that keeps the building comfortable. In commercial buildings that we tend to work with, we work with a lot of big box retailers. You know, they'll have a lot of those units all sitting on a rooftop, heating and cooling the space, providing ventilation. So HVAC is heating, air conditioning, and ventilation. That's what it stands for. It's the short version of it. But they all sit on a rooftop. And in our case, they all work together and coordinate their efforts to heat and cool buildings. But they do tend to use a lot of energy. When you look at commercial buildings, energy usage, energy profiles, heating and cooling alone is sometimes as much as 60% of the total building load. So it's significant. If you can affect your building load, if you can like, even if you think about, like, if you shave 10% off of that number and you put that back onto the grid, that's a big difference.
Yeah. So that leads to my next question. A lot of AI workloads are increasing, and with a lot of them are driven by the expansion of data centers. It's becoming critical important to save energy. Based on your experience, where do you think most companies are missing or are doing inefficiently in terms of the energy usage?
So I've been in energy and energy efficiency for the better part of 18 years. Actually, I think this might be 19 years. When I first started in energy management, energy efficiency, carbon reduction, carbon credits, all of that stuff was really new. Like, it was, people spoke about it, but it hadn't really been formalized in any way, shape, or form. And at the time, when you looked at overall building load and inefficiencies in building load, there was a lot of inefficiency in lighting. LED was fairly new. Most buildings didn't have LED lighting yet. You definitely didn't have like a nice warm LED lighting, which kind of, not everybody likes that blue light. Particularly when you're in commercial buildings and you're selling product. And so some of that adoption was slow, but there was inefficiency in lighting was 50% of your energy bill, and your heating and cooling load was the other 50% of your energy bill. And then you had a little bit of plug load, insignificant compared to those two. We've come a long way. Like, if you think about 18 years, right? We've come a long way in that most buildings that you walk into today, including residential homes, have got a lot of LED lighting in place, which reduced a good amount of the grid load. But the one piece of the market, and that's kind of why we play where we play, where there's still a lot of inefficiencies, is on the heating and cooling side, because people just want to be comfortable, and they want to be comfortable when they want to be comfortable. And what's comfortable for one person is not the same as what's comfortable for another person.
Right.
And so you have fluctuating feels on that. It's really no different to the types of novels you like. Some people are more comfortable at 68 degrees and other people are a lot more comfortable at 74 degrees. And that's a big difference in energy use on those two profiles. So there's a lot of inefficiencies that are being built into the grid that way, just because AC comes on when it comes on to meet the set point that it needs to set in terms of a comfort perspective. Our industry has lagged a little bit when it comes to optimization. If you look at your standard energy management system today or your standard thermostat, and you think about the amount of energy usage that gets tied to that thing, And then you think about the fact that the entry-level cars on the road today have actually got more technology in place to optimize their fuel usage than something like an RTU, which uses massive amounts of energy. So a
Mm.
huge inefficiency there. And it's not something that we've done a very good job of addressing as an industry. Is that changing? Yes, it is changing, but it's been slow. And then when you go and look at the creation and you look at grids, so everyone's been talking about EV cars, right? For like the longest time,
Right.
better part of 10 years, we've been talking about EVs.
Mhm.
Um, Actually, it might be longer than that now. But there's been a lot of talk about EVs, and if you're in my part of the industry, you're watching. There's a lot of mandates coming down from state and federal levels on the adoption of EV cars. And there's a lot of utilities that are struggling to think about, well, I have this much capacity. So when we talk about grid capacity, it's basically if I plug in, think about your house, all right? And you've got your switch bank. And if you plug in too many loads, it trips. Okay. Capacity is kind of the same thing, like an easy way to think about it. The grid has got, like, think of all of those little switches. The grid has got a bunch of those switches, and all the houses and all the buildings are connected up to these switches. And if it overloads, it trips. The idea is not that dissimilar. Um, so when you're looking at the grid and the amount of capacity that we have and the inefficiencies in HVAC load, which is a lot of grid stress, which is why in places like California, whenever it gets super hot, we get told, turn off your ACs and then don't charge your EV cars because the grid can't handle the amount of load,
Wow.
right?
Mhm.
So we've got problems like that, and EV adoption is accelerating. If I go to most towns now, most cities on business, and I go and get an Uber, 9 times out of 10, it's going to be it's an EV,
Mhm.
right?
Yeah.
So there is an adoption and acceleration there, and our grid has not necessarily kept up with that acceleration.
Mhm.
And now you're adding data centers. We didn't foresee data centers that use the amount of power and water that AI data centers use. That did not hit anybody's radar, or rather, it didn't hit anybody's radar well enough until the last couple of years. And so from a grid perspective, we already had a bit of a no moment coming with EVs that has been compounded. And so we really need to come to, and we're seeing this in adoption, right? Like this just last week, we were attending events with the Department of Energy and Lawrence Berkeley Labs, and the things that we're talking about there is how do we increase adoption of emerging technologies like ours that address not the whole grid problem, but individual parts of it, and with it all kind of working together. And there is a lot of AI in that. Whether it's from balancing out charging stations for EV cars, or whether it's like there's a company that balances out the way that AI data centers are using energy to drive the decision processing, um, and balancing it out across multiple data centers across the whole country. These are the things that need to be discussed and need to be adopted. And then optimization companies like ourselves, that we're working on the other big part of the grid stress, which is your HVAC side. If we're all working together, we can come to a much better outcome. And right now, that's really where like the biggest struggle is going to be. Like we've just got a lot of load all coming on at once.
Mhm.
Um, what's really interesting about the data center piece is recently there's been a whole lot of requirements now of AI data centers that when they're coming in and building them, that they actually now need to bring their own power supplies with them. So they actually have to figure out a way to power themselves. And that for right now seems to be the go forward. But there's definitely a capacity problem. We're seeing the capacity problem in places like PJM. So when you're a utility person, you talk about PJM, you basically if you look at the whole of the United States, you take a slice underneath New York, you go down to Virginia, and then you kind of make a triangle up to Illinois. That whole area is really under capacity constraint at the moment. And some of it is being definitely driven by the data centers that have been opened in those spots. So it's an ever changing grid. It's a very exciting time within our industry, but it's definitely one where we all need to be working together, whether you're a residential customer or whether you're a commercial customer, whether you're a data center or whether you're buying an EV. All of these things need to be contemplated, because having a grid go down is no fun for anyone.
Yeah.
Sure.
Driving a lot of productivity and
It is.
efficiency of working. It also brings more burden to the grid. Everything comes to electricity needs to be looked at in a broader landscape. Industrial, commercial, residential. I want to come back to HVAC. What Encycle is trying to do to improve the efficiency.
We started playing with machine learning and AI like a long time ago. So when I joined the company, it was 2008. And people weren't talking about AI the way that they were today. Like it's not the same thing. Like all of a sudden, the last couple of years, everyone's like, "Oh, AI, it's a thing." For some of us, it's been a thing for a while, and we've been playing with it and learning for a long time. Um, our machine learning really grew out of the idea of emergence theory. So, emergence theory is how do you look at nature and take the things from nature that work really well and then apply it to your everyday lives? Which is really why it's called swarm logic, because it's based on the emergence theory of bees in hives and how they work together, right? Bees aren't like they're not talking to each other, right? There's no emails, no one's on, X. There's none of that, but they do follow pheromone trails, which tell them what needs to be done in order to achieve for the greater whole, right? And that is the whole premise. So that's what Encycle does. We basically have built a whole machine learning set of algorithms that we then go and deploy into commercial buildings, either through thermostats, like if you think about your home thermostat, heat, cool, or we go through big building automation systems, like a Honeywell or a Tritium-based Niagara system, and we deploy machine learning. And what the machine learning does is basically learns in an environment what is the most efficient use of energy. So historically, if companies wanted to control their energy usage, particularly as it gets hotter, because that tends to be when electricity gets the most expensive, um, they would do what they call load shedding or load limiting, which is basically I'm going to reduce the amount of cooling or heating I give my building between the hours of 2 and 6 o'clock at night, right? Which, as you can imagine, is not necessarily comfortable because you're essentially heating up your building to save money. What we do is we deploy algorithms and machine learning into those environments, and it learns how the units perform. And it learns what the ideal set points are, and it measures the distance between set points, and it looks at thermal building load. So how warm is it going to be? What's the cloud cover going to be? Like all of these things affect how buildings operate and use energy. So it's looking at all of that in real time. It also looks at future and past states. And then it makes independent 5-minute decisions on what's the best use of energy. So if like how I tend to describe it to customers, because the easiest way to describe it to customers is like, if you had a car and you set it on cruise control, so you're driving down the road, you want to be at 65 and you set cruise control 65. You've got like some cars have got up to 13, 14, 15 different computers in there that are all constantly working out how much to use the engine or not use the engine to maintain 65 and use the least amount of gas if you're in a gas powered car. If you're in an EV, how do I maintain this and get the most out of my battery? It's the same idea. That's what we're doing for RTUs. We're literally applying that. I want to be at 72-degree indoor temperature. And how do I turn on these units or delay a unit from turning on here and there so that it's using the least amount of energy, but still maintaining occupancy comfort? And that's the key. That is what makes us so different to everything else out there, is that when we're looking at occupancy comfort, we actually don't affect it. So we can reduce Like for some of our customers, they're getting 12, 13% on bill savings back,
Wow.
which is significant, right? Like if you think about like having 1,000 sites, like you're looking at a couple $1 million that's just coming back onto your bill that you don't have to pay. And we're able to do that while still keeping it at 72 degrees. And it's hard to do. Like it hasn't always been easy. We've had trials and tribulations, as I mentioned before. We've had lots of learnings, but we do it very well, and we do it so well to the point that the utilities will actually pay customers to install us because it reduces grid requirements and it reduces the amount of energy that's on the grid or that's required of the grid. And at the same time, because it still keeps customers happy, no one's complaining.
Mm.
Like it really is like the best of both worlds. So that's what we do on the machine learning side of the world as it relates to deployments in commercial buildings.
For a residential building or
Mhm.
commercial building, right, facility,
Yeah.
what is the most important thing or one tip you would give to them in order to save energy?
Don't move your thermostat around as much as you do.
Okay.
It's a really interesting, this is a behavioral thing. Think about like the last time you go into a hotel room. People get into a hotel room and they're like, oh, it's a little cold in here,
Right.
or it's a little warm in here,
Yeah.
right? And they go play with the thermostat, right? It's very much like C button, touch button. I feel better.
Yeah. Sometimes it's difficult to work.
A lot of people don't realize that from the time that you make a change on the thermostat to the time that you would actually physically feel a difference is like 20 minutes, right?
Mhm.
Most people will walk into a room, make an adjustment, turn around, and I've literally watched them as they walk away. They're like, that feels much better. That's probably the biggest thing. Like when we see it in commercial buildings, like we see people playing with thermostats a lot, where they really, they want to be comfortable, and so they'll go and set it down. They'll, it's supposed to be at 672 degrees, and they'll go and set it down to 65 degrees because they think it's going to get colder quicker. It's not, but it is going to use more energy over time, particularly if it's really warm outside. If it's 90 degrees outside, that unit's just going to run all day. Like you're adding to the problem, you're adding to the grid stress. So I would say, even in your own home, really like sticking to what your parameters and don't play with it too much. That's really where you're going to see like a pretty significant impact, like on a thing that you can do as a person on a day to day. Um, those are really like, that's like the biggest one.
Okay. I'm
Yeah.
gonna take that as advice in my room.
Yeah. It's something that my husband and I are both kinda lucky because we're both in HVAC, so we understand how these things work. But they're like, I mean, I've watched my own family members, like, touch the button and feel better, and I'm like, "It didn't do anything, but for the next 3 hours, you're gonna pay a lot more money than you would have had you just
Yeah.
let it be." But some of these things are behavioral, and, we fight with that even on the commercial side. Like, there is a behavioral aspect to the things that we do, and there is a behavioral aspect that we have to overcome too, when it comes to commercial buildings. Um, like those are normal, but yeah, in terms of like things that you can do as an individual, play with thermostats less.
Let's transition to the sales. So how do you guys approach go to market?
For Encycle, we have a couple of different ways that we go to market. So for the most part, our bread and butter has always been our direct sales channel. Um, I kind of I fell into sales by mistake, really. Um, it's no one's dream job. Like no one wakes up as a teenager and is like, when someone says to them, "What do you want to be when you grow up?" There's not a human being on earth that's like, "I'm going to go into sales." But probably 75% of the population, we all end up in sales. But I definitely fell into it just out of pure necessity. And it's definitely been a journey, a good journey. I've learned a lot through it. Um, but when I look at like startup environments and kind of like how I've come about, so I started off in cold calling back in the day, and I was like in a sales pit making 100 dials a day, at
Wow.
an IT company. And then I met Mark and Roman through a friend. We'd both worked at that previous company. And that's kind of how I ended up with Mark and Roman, and two real geniuses. Like, I'm not the genius behind Encycle. But I have always been very customer focused. And that's really, I think, why they brought me on, because they wanted somebody that was not afraid to pick up the phone and make a call. And I'd been calling New York, and there's no more brutal a market to cold call than New York City. So I was very my hide was tough. And then I've always been very customer focused. Like, I've always wanted to be able to find the problems that we need to solve for the customer, address those. And that's really, like, when people like think about salespeople and they talk about salespeople, they always think about like the guy trying to sell them a car, or the girl trying to sell them a car that just wants to sell the car. Most salespeople aren't like that. Like, we actually really care about solving problems and about solutions. Once I was in energy, I was pretty much set. Like, the fact that I'm solving on a day-to-day basis, the fact that I'm solving grid issues, and I'm able to work within a environment that I can see a difference for the future, right? Like, I've got 3 kids. So being able to see that, like, what I'm doing, not only am I helping customers solve problems, but I am actually positively contributing to the future. That's really rewarding.
Mhm.
And I think most people in this industry, like, if you went to go and talk to like other people in this industry, they'd probably feel the same way. So we are very much like direct sales, and we've always been direct sales. Like, my sales team today, direct sales. We talk to customers every single day, and we talk to, most of our customers are big box customers, right? Like, if you think about like Best Buys and Alters and Dave and Buster's, right? Like, if you've ever been to a Dave and Buster, you go
Mhm.
look at the thermostats there. That's us.
Mm,
That's all us.
mm,
And so a lot of our business has been driven from direct sales.
mm,
We do and have been growing more and more sales through our utility channels. So we work with a lot of utilities, and we got into utilities because we worked so closely with big box retailers. So utilities and retailers, commercial buildings tend to have very close relationships, right? Because you got to think, like, a utility might have, like, if you look at like a Southern California Edison, they can have 30 Best Buys all on their grid. So they need to maintain good relationships with those customers. And they'd heard, talk of this company Encycle. And so we actually ended up, a couple of them approached us, and we started doing measurement and verification with them on our product, like on Swarm. So where we would collect baseline data and show them the savings, and everything was sub-metered. And so what's ended up happening is that we've actually ended up growing a channel into the utility market, because the utilities have got a problem to solve too, right? So customers are trying to solve an on-bill problem. They're trying to solve a reduction in energy, a carbon goals reduction. Like, those are things they're trying to solve for. The utilities are not that dissimilar. They've got a capacity problem that they need to solve for. And so they need whatever technologies that work, and that's the key. Technologies that work, they need as many of those as possible to contribute positively to the grid. And so what's ended up happening is, and it takes a long time, like, to go through measurement and verification with the utility takes about 2 years from start to finish. Like, it is a process. Um, and most companies will never, they never do it, because a lot of them won't pass, because it is like, it's intense. But once you get through that process, and that's kind of what's happened with us, as we've gone through that process, we've had utilities actually adopt us, and now they will, like Duke Energy, they will go and install thermostats, and they will pay customers, they'll pay all of the subscriptions and everything for our solution. And so that's another channel that we sell through. Um, and it's growing. So we've got market presence through there. And then the last one that we really do is when we work with our OEM partners. So, like, when we work with our Honeywells and our Tridiums, and we go and do work with EMC and TCS Basis, um, those companies, they've got customers that have got their building controls, and they're looking for optimization opportunities for those customers, because those customers, again, they're trying to solve for problems too. And so we tend to do a lot through that channel as well. So we really got three pretty distinct go-to markets. Um, it is growing though, because in the last 6 months, we launched two new products that is really geared towards facility management. And so there's a fourth potential that is developing. But that's really how we go to market. But our bread and butter for many years now, from the day I started cold calling to today, a lot of it has been driven by direct sales. Um, and I enjoy working with our customers. That's actually probably my favorite part about everything I do, um, is the conversations that I get to have with customer end users, the problems that we get to solve. Yeah. So that's what fills my cup up, so to speak.
Mm. Are you guys having a subscription model?
We
Um,
do.
yeah, okay. And
Yeah.
then how do you make sure that you continuously deliver the value to them so that they can keep subscribing and then renew the
Yeah.
contract?
So we're a full subscription model. So when we do measurement and verification with customers, because every single project that we do, for the most part, particularly with big box retailers, we start with a pilot. We will run a pilot and prove that it works, and we will run a utility grade M&V process. So if the utility was looking at the data, it would be the same thing as what they would look at. So we tend to do that because we want people to know, because we are gonna ask them for a subscription. We want them to know it's gonna save them money. So we do a utility grade M&V. That utility grade M&V is kind of where we establish the savings, and then we also tend to establish the costs as to what it's going to be. And for most of our customers, we're looking at a 0.4-year ROI. That's always kind of like the target. I can tell you now, we work very hard to make sure we never miss on them. We tend to sit down with customers and agree what does success look like, right? What is that percentage reduction that we're looking to achieve? Um, and we do the same thing once we go to rollout. And we work in lockstep on a daily basis with customers to make sure that we're either meeting or exceeding our savings forecasts. We haven't missed a number. Like, I have one customer right now that I'm going to go and visit them in a couple of weeks, and we had positioned a 0.39-year ROI, so called 0.4-year ROI, and they're literally down to 0.19 against, how much they pay us versus how much we save them. And we also spend a lot of time working with customers on their facility health. When rooftop units, like when they're not healthy, they can't do their job efficiently. They don't do their job well. And some of that's just because, if it's low on refrigerant, for instance, it's like your fridge at home. Like, think about like your fridge at home. When I don't have enough refrigerant, I can't cool the air enough, which means I'm going to keep trying to cool the air. AC units are no different. So if your AC units aren't healthy, then your environment won't be as comfortable. Or they'll have to draw a lot more energy in order to try and make their environment comfortable. Health perspective, like, how healthy is your building? How healthy are your units? How well is it running? Are all of your units connected and communicating? That seems like a basic thing. But a lot of people can't keep their earbuds connected to their phone 24/7. So now try and do that in a building full of everything from gas to water to doors to lights to, like, stuff goes offline. Um, and all of those things do impact how well a savings model is going to perform. And so we do work very, very closely, not just to ensure that, one, we're hitting our savings, but also, hey, here are all of the opportunities that all the ways that we could make the building healthier if you address A, B, and C, that will generate more savings. And so we look at multiple different things. We also do a lot of work on demand response, which is basically emergency grid response. So like when a grid's like very under water in terms of capacity, we can do emergency response too, where we can be even more aggressive in dropping building load. But again, that works better if the building is healthier. If the building's not healthy, that becomes very hard to do. So it is an ecosystem. And some weeks we're looking at HVAC efficiencies and health, and other weeks we're looking at savings against forecast. But we do that in lockstep with customers on a daily
Right.
basis.
Yeah. Who are your like target audience? Are they energy managers, utility managers, or someone else?
It's a good mix. So most of our customers today are energy managers or facilities managers. They're either responsible for a energy bill, paying the energy bill and reducing the energy bill, or they're responsible for keeping the buildings healthy. That's a lot of our customers that we work with. Like most of the people I speak to on a daily basis are those people. But since we started doing more work on the utility side of the house, we do now actually have a lot of conversations with the utilities. And those conversations are going to be more driven around reducing overall grid capacity issues. Um, so I would say energy managers, facilities managers, VPs of facilities, we even talk to sustainability people, right? So like the director of sustainability, they've got a report on an annual basis, um, carbon reduction. Carbon reduction tends to be, you've got scope 1, you've got scope 2, and now a lot of people are trying to address scope 3, which is much more difficult than scope 1 and 2. But these are people that are trying to meet greenhouse gas emission reductions. And that's not always an easy job to do, because you're often dictated to what the target is, but you're not always involved in helping set the target, if that makes any sense. And so those people are people that we work with them, and we will give them what our savings are, and we report to them, and they're involved as well. So you've got, like, if you look at a lot of these commercial companies, you've got sustainability, you've got energy, and you've got facilities. And they look like three distinct departments, but they all actually work really closely together because they are all tied together. Energy impacts sustainability, facilities impacts energy usage, which impacts sustainability. So we tend to work with a lot of those. But yeah, and then now utilities. We are starting to work with a lot more utility people. And with the utility people, we tend to work with programs. So we're working with people that are building programs. We're working with people that are looking to incentivize, because usually you have to incentivize customers to do things. People don't just change a behavior because you'd like them to. There's usually got to be an incentive to change a behavior. So they build programs, and those programs get managed by program managers. And we also work with the account managers. So with a lot of the utilities, there's an account manager that's responsible for specific accounts. So like I'll work with the account managers that are responsible for Best Buy accounts or Burlington accounts, particularly if we're running incentives. So if we're doing incentives for those customers, then we'll work very closely with the M&V teams. So yeah, it's a group activity. It's definitely a group activity. It's a big SAMP, and there's a bunch of us playing in it, from the utility to the customer to us in the middle. And we're kind of the widget that makes it all come together.
Yeah. It sounds like when it comes to a group activity, some people can easily buy in your idea. And you mentioned a lot about the behavior change and then the comfort level, right? Who can tell what is a comfort level? Everybody can have different definitions. So when you are talking to your customers, who tend to push back more, and how can you give us one example, and how did you convince them to get to?
Yeah. Yeah. So, I think a lot of the time when it comes to behavioral stuff, the people that tend to push back the most are facilities teams. Um, and it's not because they don't want to do projects. It's because ultimately, if someone's uncomfortable, they're the ones that get the call. And that's never a pleasant call, ever. Um, so, when you go to some customers with new technologies, and you put a new technology in front of an energy and a facilities team, the energy people tend to go like, oh, this helps me reach my goals, and I need to do this. And the utility is going to pay us to do this. So like it all looks really good there. On the facilities side, they look at it and they're like, you're going to reduce energy. What am I sacrificing for you to get that reduction?
Right.
Right? And
Right.
that's a very natural, there's nothing wrong with that. It's a very natural, very normal approach, because historically, if I wanted to save energy, remember I was talking about load limiting and load shedding, and back in the day, if you wanted to save energy, you had to turn off heating and cooling, right?
Right. Right.
But when you turn off heating and cooling, the first people that get a phone call are facilities to say, yeah, turn it back on. I'm not happy, right? So you've got facilities. So there's different goals for each team. Yes, they work together and they influence each other, but they have got different goals and they're measured by different outcomes. The energy team is measured by how much energy they reduced, how well they use their budget. Then you've got, and the thing is with energy is like, you've only got so much that you can control, right? If the electricity bill goes up, if the utility increases the rates, that's out of your control. As an energy manager, there's nothing you can do. So you're constantly needing to look into your buildings to see how can I make them use less electricity, because I can't control the price of electricity, but maybe I can control how much of it I use, right? So that's the balancing act that they're playing. You've got the carbon and sustainability guys, and they're like, well, we need to reduce the amount of energy we use because it counts towards our carbon reduction, and we have to publish this stuff, and it's very, very important that we're meeting our goals. And then you've got facilities, and they're like, look, I only get so much budget, and I have to make sure that my building is running and that it's comfortable with this much budget. And if people are uncomfortable, then it's going to be my fault. And I could potentially, if you're a big box retailer and you look at, well, if people are too uncomfortable and they start leaving my building, that's an impact to revenue. And then that becomes a big problem, right? Because there's a lot of eyes on that.
Right.
Those are the things you're dealing with. So what we do with a lot of our POV, so when we do pilots, yes, we're looking to prove energy reduction, right? We want to prove that it works. But part of that is proving that we are got energy reduction without negatively impacting occupancy comfort. And so we measure baseline comfort against swarm enabled comfort. So once the machine learning's turned on and doing its thing, what is the comfort differential under the two different environments? And we show that, and we use the EMS data. So we actually use their temperature data to prove. So we're not making up numbers. No one can accuse us of making up numbers. It's very, very important. But that's really the best way to overcome the facility's concerns that you're going to save me energy, but what am I being asked to give up in terms of comfort to get that savings? That's the biggest challenge that we face. And so that's the piece that we really have to get, like, yes, we got to prove the savings, but having the facilities team see that I'm not going to make their lives more painful. I'm not going to increase their hot calls. Those pieces are incredibly important. And so that baseline for measurement and verification for energy efficiency and reduction is as important for comfort. And so we spend a lot of time working with those folks. I mean, we've even gone down to tracking. We'll go and track the number of hot calls before and after. We go all the way down into the weeds. Because it's really important. You need your facilities team they need to feel comfortable. If they don't feel comfortable with it, they will absolutely make sure that you do not deploy in those buildings. So it's an incredibly important part of what we do.
So be transparent and show them the data.
No hide. There's no smoke and mirrors, but and not every company runs like that. It's one of the reasons that we are utility endorsed, right? Because you can follow from point A to point B and you can see where it went. There is no hiding. When we provide calculations to customers, it's all open. They can go through the whole thing and see how the calculation. There's no, this cell is locked. There's none of that. We don't play those games.
Yeah.
But yeah, it's crucial. Most big box retailers, even if you go to a shopping mall, there's so much technology in place now that they can track where you go and how you shop and where you spend your time, and they'll move products around based on how people move through stores, right? What goes on the end cap, what goes on the main shelves, what goes in why would you put a different product in the back versus there's a whole science there. And one of the things that they calculate is how much money do I spend based on how much time I spend in my store, right? There's a dollar value, and the more time I spend, the more that dollar value goes up, right?
So that's what you facility manager wants.
Yeah, I mean, their job is to make sure that they're not giving you an uncomfortable reason to leave the store. They want you just right.
Mhm,
Like an even 72 degrees, no humidity, nice and comfy, right?
mhm.
That is their job.
Yeah,
And
yeah,
that is what their budget is for. So yeah, we spend a lot of time working with proving that I'm not going to affect that. I'm not going to create a headache for you. I'm not going to increase your hot calls. And the store's not going to get shut down because people are passing out. That's really, really important.
mhm, yeah. So, AP, I wanna, switch gears and ask some questions about your role as a CEO. You started in the company back in 2008 as a sales, person, and now you're a CEO. Can you maybe tell, us about your journey and what led you to this role, and what are the changes, you wanna bring to this role?
Yeah. I started in sales. I intended probably to finish my career in sales. I never envisioned becoming a CEO. It kind of like the cards, that's just the way the cards landed, really. Um, so when I started with the company in 2008, I was a salesperson, like in the trenches selling. Um, I was always our top salesperson. I understood the technology really well, pretty much from the get-go. Um, my dad's a chemist, and so we spent in my childhood and my teenage years, like I did physics and chemistry at school, and so I could understand these like grids and energy and electricity and how these things get used, which is very helpful. And then of course I got a marketing and advertising degree, which is really a degree to like make things look pretty and communicate well. um so like you put those two things together and boom, I have a career in energy. um I spent a lot of time on the sales side, and I love the sales side. I still love the sales side. Even though I definitely fell into it by accident. It's something I've enjoyed. I did leave Encycle for a time though. So I haven't, like, if you go look at my LinkedIn, what have you, there's a stint where I left the company for a bit and I went to a different company because I so every single salesperson, you come to a point in your career where there's kind of like a fork in the road, and either you're going to stay as what they call a individual contributor, which is I'm always going to be the salesperson,
Mhm,
right? Which is a good path. And then there's going to be others of us that are like, okay, I enjoy sales, but I want to go into leadership. And everybody's decision on sales is different. And 9 times out of 10, I find that when people decide they want to go into sales leadership, it's because they think they're going to make more money. That is incorrect. So for any salespeople watching this, if you want to make more money, stay on the individual contributor side because your commissions are always going to be rock star. Um, but I was looking for a leadership role. Like I don't get me wrong, I enjoy making money, I enjoy the commissions and what have you that sales brings, but I did want to learn more on the leadership role. And I was not being given that opportunity at Encycle. So I can kind of understand why to a certain degree. Like it's really hard to take your top salesperson who has always been your top salesperson and you're like, oh, we're going to take you out of that role and now we're going to let you lead it. That's a difficult decision for a company to make. So I unfortunately had to make the difficult decision that I needed to go elsewhere to get that experience, and I'm glad I did, because I learned a lot going elsewhere. And then I came back to Encycle like 4 years later, and by that point Encycle was no longer a science project. Like we were at one point, like all AI companies, we were a science project. um at some point there is a bunch of gearheads in the back thinking about really cool things. And we went through that. That is in our history. But by the time I came back to Encycle, it had come a long way. It was purely software based. It was a single file load. Like we can literally turn on hundreds of buildings in minutes.
wow.
Yeah, like it's not a science project. It's a scalable solution today, and it's really amazing to have seen that growth. Um, and I came back as a sales leader and I came back as the VP of sales. And then a couple of years ago, I was lucky enough to become the owner of Encycle. It wasn't something I was expecting to have happen. Like if you had asked me at the beginning of 2023 how 2023 was going to end, I could not in a million years have forecasted that I was going to end up being the owner of Encycle and the leader, the CEO. Um, but yeah, that's really how it happened. There became the opportunity for me to take ownership of Encycle and become the CEO. And I've had such a long history with the company and I understand the product so well, and I know the customers so well. And it felt right that it needed to stay with the originals. Um, and the originals, I mean, our company is like, if you go look at the average tenure of people at the company, most people at the company have been here 10 plus years. Like we've been in this together as a team for a long time. Um, and I think that's one of the reasons the product's so good, right? Like it's not a revolving door. Um, and we understand the problems that we're trying to solve and how we solve them. But that's really how I came to become a CEO. I don't know if my life has changed that much being the CEO versus being the VP of sales. Um, I have a lot more administrative stuff that I don't necessarily love as a CEO. But I still speak to customers every day. I am still involved with all of our customers, and that bit of it, I don't think would ever change. Like if you're a CEO and you're like our company, we're at a critical time, right? We're profitable, we're growing. Um, I probably will always stay involved with customers. And I also feel like because everything we do is customer focused, the only way it can be customer focused is, you've really got to be involved with those people. You've got to understand the problems you're solving and the problems that they're facing. Cause you never know, like even like the two new products that we launched in the last 6 months, those came from customer conversations. Those came to solve a problem that a customer was, and we could see the solution. And then we worked with the customer to build the solution. But I think because I come from a sales background and I'm intimately involved in those pieces of it, and I have remained intimately involved, I think that's where we have some of our new growth is coming from. Um, but yeah, that's really how I felt into becoming CEO of Encycle. It was not a planned event by
Mm,
any stretch of the imagination.
mhm. Yeah,
I'd do it again though.
you've come a long way, started all the way back to 2008. You mentioned earlier it started as a science project and now
Yeah.
it's a software.
Yep.
And then you also mentioned you did a lot of like measurement certification that route took
Yes.
years. How did you know that was the right direction you wanted to go? And then to what point you feel like, hey, we're hitting a product market fit and we could grow really fast?
Yeah. So there's a couple of iterations in there. So when I first started, it was definitely a science project, right? It was Mark and Roman, right? The two guys, geniuses, innovators. Um, One is a mathematician, one an engineer, right? There's no bigger nerds in the world. And I'm a big nerd, so I say that with love. But they had an idea, and the idea was sound. And this is where like the machine learning pieces come in, right? Like you've got an engineer and you've got a mathematician, and at some point you're going to end up with like amazing algorithms, but it takes time to get there. At the time, building automation systems, because they're antiquated, but as an industry, we really have not, like I said, like your entry level car today has got more technology than your average brand new out the box building automation system. It's actually it's a little sad, but this is just where the industry's at. And it's getting better slowly, and it is getting better. But when we first started, you couldn't even, half those building automation systems, you had to dial up, right? You're going back 18 years. You're not deploying machine learning through a building automation system. That's not a thing. Um, and so we were installing controllers, and they were like a baby blue controller. And I do mean a baby blue controller. Some people would tease us about our baby blue controllers, but that was the color that Mark and Roman picked. So we would install these baby blue controllers, and we would put on sub meters. So actual, what they call CTs, current transformers. We would put them around the mains, and we were measuring actual power usage of the HVAC units in real time. And then we put a cellular modem, and that would all get communicated up to the cloud. And we did that for the better part of 13 years. And those first couple of installs that like I sold and did, they were not perfect. Some of them didn't last very long, right? Because at the time we weren't necessarily looking at internal temperature. we were just looking at the sub-metered load, and we were looking at duty cycle and how different, because RTUs have what they call a duty cycle, which is like how much time does it spend heating or cooling versus how much time does it spend at rest. And you usually look at it like in a 3-hour window. So, and you would assign a percentage. So how much of that so if I ran like 2 hours out of my 3 hours as an aggregated amount of minutes, I had a 66% duty cycle. It's very mathematical. And then at that point, it was doing maths. Now, the algorithms were doing the maths. Like they were making decisions. They were communicating with each other. They were communicating where they were in their duty cycle. And then they were making independent decisions as to whether they should open or shut relays based on where they were in their duty cycle and based on what all the other units were doing with their duty cycle. And it sounds like a basic application. But we did learn a lot from those very early days. And we successfully deployed that technology on 30,000 RTUs in North America. So, we still get calls today. If you call our support line, our support line still gets calls today about, hey, we found this blue box with your number on it. Right? So like that technology, like it's still out there on some of the rooftops. And that technology we used for the better parts. So between 2008 and 2017, we were installing those controllers and we were collecting that data and it was making decisions. How it was making decisions was by doing that optimization. And it worked really well. It saved people a ton of money. And more importantly, it built us the most phenomenal database probably ever to exist on actual sub-metered RTU load, which again, super nerdy. But when you're looking at how different mechanical things perform and use energy, that data is really informative. And that data has become, that's part of what we do today. Like that's part of our smarts and our secret sauce. Like that is part of it. That 13 plus years of sub-metered load on RTUs. And then having progressed that through to where it is today. So now it's completely software based. And some of that needed to be like some of that get out of the science project piece. Some of that really came about because of advances in EMS connectivity and thermostat connectivity, right? So like if you think about like, I want to say 2009 was the first time that I really ran into there's a company called Ecobee. You may have an Ecobee thermostat in your house. Ecobee and Nest are the main thermostats installed in most people's homes today. It's either one or the other. And those were really the first Wi-Fi thermostats that people were getting used to, right? Like everybody knows what a Nest thermostat is, right? Everyone knows what it looks like. Everybody knows it connects to the cloud, right? And if you think about just in the last 15 years, how far you've come in residential, right? Where you've got automated light switches and automated door locks, and now you've got cameras watching everything around your house. Like we've come a long way. Energy management systems haven't come quite as far as quick, but they've gotten connected to the internet. So they can now communicate to the cloud. And when we're looking at that infrastructure, that's really the piece that we needed to help us become less of a science project. Because when we were still installing those controllers and doing it by duty cycle, we were missing some fundamental pieces. So we were pulling in thermal load already and using thermal load in our modeling along with the duty cycle. But the pieces that we were missing was internal building temperature. So the assumption that a unit is going to perform and requires to pull X amount of energy over time to sustain internal temperature is not inaccurate. But what it doesn't account for is changes within the building that you may not necessarily be aware of. The moment that you get into a building automation system or into thermostats, because we do both, you get a whole nother layer of visibility that you didn't have before. And so that is where we've actually found our acceleration. That's where we've got to 5-minute decision-making process. So we went from 15-minute to 5. And now we're not just looking at thermal load and energy performance, but we're also looking at temperature differentials within the building and how quickly those temperature differentials are changing, right? So with all of that, the models are getting better. Everything gets better. It learns quicker and we can apply more to it. And that's really where it's solidified. And then where we really got our growth, like that moment of like, aha, was when we started working very specifically. So we don't do chiller plants today. We don't do chiller plants, which is like if you think of New York City. I was just there last week. Think of New York City. Everything is big, tall buildings. And if you like do a Google map view, you see all these fans on the rooftops and they're all kind of huddled together. That's what they call a chiller, and that's usually cold water loops cooling. There are a lot of companies that do that, and they do that really well. We're like one of the only companies that do RTUs, which are the big boxes on retail stores. And once we realize that doing it in those retail stores, that is very much a repeatable, right? If you go into a Target, there's only so many different types of Targets. They tend to have like an A layout, B layout, C layout. Best Buy's the same way. Walmart's the same way. Like they've got certain specific layouts, but that's where you can get really, really quick in when you apply your technology. So like our learning period, like when you speak to a lot of companies that do like AI learnings, they're like 6 months. The AI model needs 6 months to learn how this building operates. And then we need another 12 months to prove that it works. Like that's 18 months. You're
Mhm.
looking at 18 months commitment. We have gotten it down all the way to the point that we install Swarm, we connect it up, everything gets mapped within the building environment, and we turn it on, and it learns on the fly now. Like we're not requiring a 6-month learning model. It's literally, but it's because we tend to stick to the same types of building types, right? And we've learned a lot because that has been mainly what we've installed on for many years. So we've learned a lot about those environments, and we do them really well. Will that change over time? Will we grow? Sure, we will. There's other products that are going to be coming out that are going to control other things. But today that has been, and that piece of it, we have really worked on. But like we're going back 2008, right? I mean, we're nearly 20 years of learnings in this thing by now. Um, but that moment once a building automation system could be connected up to the cloud, and you could now use the power of the cloud and pull in data from the EMS and pull external data and marry those two things, that's when we stopped being a science project. That was 2017.
Mhm.
2017 was the first time that we did a deployment that didn't look like a science project. It tells you how much work went into it because I started this in 2008, but it works really well now.
Yeah, amazing. So AP, let's look forward. What are the innovations you want to see
I
in
want to see.
yeah.
I want to actually see people embracing AI without the fear. I hear so many times that people will say, "Oh, I'm afraid of AI. It's going to replace me. It's going to replace my job." There's all of the skepticism about it. And, AI is a tool. I mean, that's how I look at it. It's a tool. Um, it can make things more efficient. It can make things faster. And anything that is a repetitive thing that we do on a daily basis, you can give that to AI to run, and
Mhm.
it will do a really good job of it.
Mhm.
Um, and I think that there's a lot of fear, and maybe that's because us in the AI industry, we haven't necessarily been very good about talking about why not to be afraid of it. And everybody has seen Terminator and are convinced that that's what's going to happen. Um, but I think as an industry, I think we need to talk more about the things that we're going to do well with AI, um, and how it can improve efficiencies and how it can bring more joy to your job. I mean, there are things that everybody does on a daily basis they don't want to do. When I look at facilities teams, like, and this is like some of the problems that we're solving today outside of the efficiency world, but we're now into a world where we're starting to use agentic applications and LLMs and generative AI, and we're not necessarily using those things. Like we've still got machine learning for the efficiency piece, but we are starting to build products that are around workflow optimization.
Mhm.
And within my industry, or if I look at my industry, so many people for so many years, they always talk about, "Well, we want to be proactive on maintenance and we want to be proactive on building health,"
Right.
right? And there are
Right.
a lot of companies, like if you go put in proactive HVAC maintenance into Google, it will tell you all of the companies that claim to do it.
Yeah. Right.
None of them do.
Same for the factories, right? The
Yeah.
automobile manufacturing.
Everything in my industry is still driven by this thing, which is a phone call to say, I'm too hot. That's what drives the industry, the whole facilities maintenance industry. It's this thing to say, I'm too hot. And it's not because there's a lack of data. We have lots of data. There's so much data.
Mhm.
But it's the building the data and putting it together in a way that drives ultimately a decision and an improvement in workflow. And I actually think that that is where AI, for what in my industry for facilities, I think that's where we're going to see the next leap. um, is where you've got companies that are building things that make facilities teams' lives easier, that can stop that call, properly stop that call before it comes in. Not, well, I dispatched a truck like an hour ago because I noticed there was a problem. Like, hey, we knew that there was a problem 60 days ago and we already ordered the parts to solve the problem, and it's literally will be fixed next week. The tech will be there.
Mhm.
It's that changing in perspective. I do think that there's going to be there needs to be a massive leap there, because that part of the industry is very antiquated still. And we've got a massive amount of knowledge leaving it too, right? A lot of people, and this isn't necessarily an AI thing, but from a skills perspective thing, we are losing a lot of skills. As the boomers are retiring out, we're seeing a lot of HVAC techs that, these HVAC techs, they could turn on a unit, kind of like a mechanic with like an old car. Like if you think of like a Mercedes Benz, my grandfather was a mechanic and he used to drive a Mercedes Benz. And I was amazed as a small child how when he turned that thing on, he could tell you what was wrong with it just by the sound it made. HVAC techs are like that. Like the really good ones, the really seasoned ones, they can look at a unit, hear a unit, see a unit, and know kind of where the problem is. And all of that skill is in the process of retiring and leaving the workforce. And unfortunately, what's coming in are green, young humans that theoretically have learned from a book at college how these things work, but haven't seen it. And so I do think that the more, and I will say though, those individuals, they're not necessarily afraid of AI. They're actually probably quite,
Embracing. Yeah.
yeah,
Love with AI.
they are. They are. And so I think that the more that we can take this really amazing data, right? So like we're not one of those companies that's like, we're gonna build AI and then the data is like hokey. Cause like we know it's no different than Salesforce. Crap in, crap out. It's the same thing. AI is the same thing. The data's gotta be good. So we got lots of data and it's really, really good data and it's been well cleaned in our case. But if I can put that into a package that I can then go and put into a facilities person or a young tech's hands that shows them where the problem is, that makes their lives easier. That makes their service calls better. That makes their time to fix quicker. That makes the facilities manager's life easier. Really, like if we can just take all of those data, I mean, there's tons of data lakes out there. Some of these companies have been collecting in data lakes for years. If you could just enable that and just put that into all of these young skills that are coming up that are replacing the skill that's leaving. If you can build tools that takes that data and makes it an actionable decision for them and shows them where to go, that is where honestly, I think that's what, like when I look at the marketplace and I see the problems, that's where I see the next thing's going to be. There's going to be more on optimization. There's definitely going to be more in energy efficiency because we're going to be forced to. Um, but I think a big part of that is actually just putting the decision, making the decision process easier and quicker. Like there's so much opportunity there. I definitely think how we use it is more on the facility side.
Thank you for what your company has been doing to reduce the great stress. I want to also say a special thank you to Jen for making this interview happen.
Yeah, big thank you to Gwen Chen. She's been with us a long time, and honestly, I couldn't imagine life without her.